Okay. Hello. Hope everybody's doing well. I am Dr. Nashley Cephas, and I'm a tech evangelist with AWS. And today we're going to talk about responsible use of AI and ML. So let's get into it. So, as you know, the reach of AI and machine learning is growing astronomically. Everywhere you look, you'll see these technologies being used in some type of application. Um, Lots of growth happening. There's no doubt about that. So what is responsible AI? I've mentioned it a couple of times. When we say responsible AI, we know that with the growth of all AI that is to come, that we must use it responsibly. And we'll talk a little bit more about what the different components of responsible AI is. But our commitment is to develop AI and machine learning in a responsible way. And we know this is integral to how we build AI and ML services, especially at AWS. It's integral to how we engage with our customers, and it's integral to how we innovate and build a more equitable future. A lot of times you hear people say that the future of tech is equitable, the future of tech is accessible, and the future of tech is inclusive. And we want to definitely vouch for that and continue in that motion. So, what is responsible AI and those components that I was talking about? Well, one is privacy and security. Uh, Basically, we're saying, is the data used in accordance with privacy and legal considerations and protected from theft and exposure? Something that really should be considered in all applications, whether it uses AI or not, but especially in terms of AI because of the core of AI ML starts with the data. The second component is fairness and mitigating biases, in other words. So, are there harmful disparities in system performance across subpopulations? And I shall say mitigating unwanted bias because sometimes, to be fair, it's okay to have certain bias if it is built for a particular, demographic, for example, or a particular subpopulation that you do want to have some disparities for. For example, the third component is explainability. Does the system offer a clear rationale for its decisions? However, on the flip side of that, you don't want it to be so clear where someone can come and reverse engineer your whole system. So keep that in mind. These are very primitive areas of research, by the way, so we're still evolving. The fourth component involves robustness, and how hard is it to confuse or fool the system, such example with adversarial examples. We'll talk a little bit about that as well. And lastly, governance, which is just as important as all the others. How do you actually enforce and ensure that people are actually doing and carrying out these practices? So, why is it complex and how can we succeed? Well, remember that success is very much so use case specific. You want to make sure that you're simplifying and defining whatever the specific use case is so that you can measure success against that. This can be somewhat technically hard. So again, it may require you thinking outside of the box, invent and simplify for all DevOps steps. I often say that creating a bias report or an evaluating your system for bias can be an entirely different research experiment. And oftentimes you have to source different data and think about different types of use cases that you normally wouldn't with just the pure software development. And lastly, rapid changes in AI landscape can cause things that may not have caused any, bias or robustness issues in the environment before, but as the environment changed over time, it did cause or introduce bias. That model did. So remember to improve continuously over the long term. So the awareness of responsible AI is growing, fortunately. 76% of CEOs are concerned about potential bias. Most managers think responsible AI should be on the top of their company's agenda, which I definitely agree. Also, a growing number of global legislative proceedings are focused on responsible AI, which makes me, very happy to see that many legislators organizations and institutions are often, enforcing policies that they're not even sure about how the technology works. And so it's definitely good to see that more people are getting more and more focused on this type of topic. 94% of companies are struggling to operationalize AI. So progress is somewhat slow there. And to really think about it, if it's not been done before, it really takes time and attention and effort. And the proper amount of resources should be allocated to that to actually operationalize it. So these are things that we deal with and work with our customers on a daily basis. So we talked about long term, over time, responsible AI being something that should be at the forefront. Well, that's definitely the case for machine learning, the machine learning lifecycle in general, but especially when you think about fairness and explainability. So when you think about the first step being the problem formulation, the problem formation, you think about, is an algorithm an ethical solution to a problem, or is it much more to it than that? Sometimes there are systems that proceed and then come after the actual algorithm portion of the solution that need to be evaluated as well. Uh, in the data set construction, is the training data representative of different groups that are actually gonna have this technology be used on them? Are there biases in labels or features? Does the data need to be modified to mitigate bias? In terms of biases in labels, think about how your data was annotated, especially with commercial data sets or open source data sets. You want to make sure you do your due diligence in making sure that those were properly and ethically sourced. In terms of algorithm selection, as a someone who's been training models for over almost a decade now, you have to think about, does fairness constraints need to be included in the objective function? There's so many different models out there, so many different ways you can choose to train an AI or ML model. And so think about the differences amongst the different types of algorithms. Also, the training process, which is pretty much self-explanatory. Once it trains, you must test. Has the model been evaluated using relevant fairness metrics? And those can change again depending on the use case. Are there unequal effects across different users? So think about not just the end user, not I'm sorry, not, think about not just the customer that you're selling the service to or the product to, but also consider the end user, which are not always the same person. Now, is this model deployed on a population for which it was not trained or evaluated? Also, remember, does the model encourage feedback loops that produce increasingly unfair outcomes? Whatever solution you have in software, whether it's a simple mobile app or a web application, you have to continuously, as a good producer of technology, you want to continuously monitor the feedback that's coming from that. And again, this goes in a circle continuously. It's an iterative life cycle. So we want to make sure that we're supporting the entire machine learning lifecycle when it comes to responsible AI. I know at AWS we have an end-to-end portfolio of services, tools, and guidance to help you. And so there's also tools like SageMaker Clarify that helps you detect potential biases in data. There's the AWS Data Protection Services where you can help get data labeled accurately. You can choose types of people that you would like to annotate that data from different demographics and backgrounds. And we help you with that with our experts that we have in-house. We also have SageMaker Model Monitor that helps you detect inaccurate predictions and alerts users. And several of the suites and tools within SageMaker allow you to monitor your model, over time to prevent things like model drift. Like when I was talking about when the environment changes and your model no longer becomes as relevant or as fair as it was when it was first deployed. So I hope that gives you some background on what we mean when we say responsible AI. I know this is a tech talk. So let's get into the use cases. One I would like to talk about today is in terms of face technologies. And so we have a few examples of how we think through these problems from a case study that we pulled from a little while back. So let's start with just kind of defining what we mean when we say face technologies. So there's something called face detection, which means detecting if a face is present or not. I want to make sure I define the different types of face technologies so we can know that every different type of technology deserves its own way of evaluating for biases. With face detection, for example, you can take different types of skin tones or genders and understand, are all faces in whatever environments, whether it be I'm in a background with a flag or a beach, are all backgrounds and all faces detected in a way that doesn't reveal any bias. Secondly, there's something called face analysis. And so this is an example of face analysis, an API that returns several different um, attributes about a face. And so there are things in there such as eyeglasses, whether or not the person's wearing eyeglasses, whether or not their mouth is open, returns a true or false. There are several services that do this, and each and every one of these attributes, for example, or features in this particular API can again be tested for biases in its own specific way. So you can imagine if there are over 15 to 20 different features detected here, there should be at least 15 to 20 different types of labels and data sets that you're looking to actually test for bias in this system. Also, I will just say really quickly, I'm gonna go back and just mention that we understand that ideally, especially if you work at a startup or a company that doesn't have as many resources, that this may seem a little overwhelming to test for all these different types of biases. So we do recognize that, but understanding that definitely give it a try and just start somewhere. Pick, for example, the top 2 or 3 attributes that are most sensitive or pertain to certain particular protected groups or marginalized communities, and prioritize those, and then slowly work your way through the rest. But I guarantee you, as a company, if you put these things at the forefront at the beginning of your conception of whatever the software tool or AI technology is going to be, you will definitely come out better in the long run. So the other type of face technology I want to mention is face recognition. And so there are many types of face recognition. Again, all different types of bias testing. And so, for example, if your technology involved face one-to-one face matching, this is the type of technology that we use often if you're trying to unlock your phone, for example. You want to make sure that you have several different types of data, and to make it really robust, you want to make sure that the person, maybe the twin of that person, or someone who looks similar to that person, like a sibling, is not able to uh, you know, uh, be accepted as a one-to-one match. And so this also means taking that one subject in many different environments, many different backgrounds. Are they smiling? Maybe get different ages of the person, depending on what your application is. You may want to see them with different types of hairstyles, even. And so it's very important. And the scene around the person sometimes can bias your algorithm as well. So definitely check for that. Now, when it comes more so for one-to-end matching for face recognition technologies or Face ID, for example, you're trying to see which person in the database of many faces is the closest match to the inquiry image. And so in this case, you're going to want to test for several different, not only several different types of pictures of the inquiry person, but also in various types of backgrounds, and making sure that the data that you're training on has many different types of images for people they have different hair type, skin color, background. Also try multiple pictures of that person in that database to see if it recognizes them in different environments, for example. So again, just trying to help you understand that there's can be many ways to do this, and it's not always trivial. And also, sometimes we take it for granted that these data sets are available, and sometimes they're just not. Another thing I want to talk about is the confidence score. This is something that is, if you're, in AI ML training models, you're probably familiar with it. But oftentimes, those who operate these type of technologies, if they're not in that field, they have no idea what this is. So the confidence score is very important. Anytime you train, for example, a neural network model, like a CNN or something like that, you are going to get a confidence score returned for every single result that comes from the model. And this is true amongst many types of services, and it's probably the most common feature in an AI ML model. And what we want to do is make sure that for whatever your application or whatever your use case is, that you're using this confidence score based on the history of what you've seen in the way you've tested your technology. And so you may want to threshold your confidence score and say, I only want to return results that are above 99%. Or you may want to make it more loosely coupled to the confidence score and say, hey, I don't really care that much if I get a lot of false positives. That actually helps me. For example, if I'm trying to find a particular type of dress, but I don't want the exact dress, but I want dresses that look similar to it because I may already have that dress. And so I want to see additional false positives if I'm trying to match it to that dress. So I may lower my confidence score to something like 50%. And so again, how do you test this for bias? Well, maybe your confidence score is not very reliable, or maybe um, it doesn't really align with all the different types of tests that you're doing. And so if you're not seeing consistent confidence scores for similar types of images, then that may require more training for your model. And you may actually bias your model by setting a confidence threshold for something that you haven't really got a good understanding if this confidence score is reliable or not. So keep that in mind. Now, another thing to keep in mind in face technologies and face recognition in particular, and again, whatever your use case is, you're going to have to keep in mind what are some things that cause your model to fail, just period, even outside of the area of biases and fairness. So, in faces, for example, sometimes having the sun shine on your face, it occludes some of your face. It causes some of your features to be unseen, and so it can cause errors that way. Different viewpoints and poses. You want to make sure you're testing for that sort of robustness. Aging, like someone who looks much older may not match with themselves if they were, took examples of their face when they were much younger, or if they had on makeup. Also consider, facial hair versus different hairstyles. All of these things make it difficult in general to do face recognition, even though our technologies are becoming more and more accurate today. But just keep these things in mind because you still have to account for the traditional ways that your model can fail in addition to your bias testing. So, where can biases exist? So, we're about to walk through a case study that shows some examples of this. So back in 2018, there was a paper called Gender Shades that um, was written by Joy Bulumwani and her co-authors that indicated that there was at Amazon, our face software, when performing gender classification, had a much higher error rate for darker skinned females than all the other combined error rates of the system for that particular data set, which was called the PPB data set, which is a parliament data set. These are members of, government officials and parliament for different countries in Africa and then in Scandinavia. And so the study was to see how well gender classification performed on these individuals. And so I want to just kind of say that in general, face technology has been relying on data sets excuse me, that have been biased towards oftentimes white individuals or faces of white individuals. These are just some of the breakdowns. This was actually pulled from a paper called Fairface that was published in 2019, and all of these are various face data sets that were in used at the time. A lot of algorithms were using to train and test on it. So this just shows an example that there are, even though something is publicly available and sold on the market, it doesn't mean that it's the right data set for you. So definitely do your due diligence. And so some people also, I'll just mention before we get into the study that oftentimes faces are automatically or simulated or generated. So these, for example, are all fake faces that you're looking at. This was created by NVIDIA, an algorithm that they were using, a paper that they published in 2019 that uses GANs to create fake faces. And so, uh, of course, some people use this technology for good to, try to create faces that can help you train your model in a preliminary way or test your model in a preliminary way. But also, some people use this technology for bad in order to do things like fool people or fool the system or get additional pictures or even videos if you've seen things like deep fakes. And so using the technology is important to know. I want to make sure that I use it in the right way and use it for good. But the intent in the face recognition world amongst scientists is to use the this algorithm to create additional faces in order to test on before you test in the wild. All right, so getting back to the PPB analysis or the gender shades analysis, I mentioned that um, basically there was a discrepancy in the error rates for gender classification amongst this particular data set that was tested. And so what we did back then was we actually created a Jupyter notebook where we used on SageMaker to be able to create um, you know, these testing and data analytics and bias report tools to help us automate some of our testing and investigating into why we were showing this discrepancy in error rates and a disparity. So the first thing you want to do is, always double check the data. Everything starts with the data. And again, this is the data that we were using to test the gender classification, not to train. So that's totally different thing. But just coming up with data sets to test your system is a separate project in itself. And so ensure that you know what is the makeup of that data. So we're calling this the PPB2 data set because we were able to get access to a copy of the data set. It was slightly different um, than the original, but overall, it was pretty much producing the same results. It was just a later version of it than what was published in the paper. So we at first tried to see, did we get the same matching results as they did in the paper. So make sure you can reproduce the experiment, and then two, make sure you understand what the makeup of it is. You can see it's almost even amongst male and female, less female though, and not that that's a bad thing, but just understand that going into it, and then also look at the breakdown of the subgroups. So male and female, both lighter and darker skin. We were seeing this sort of breakdown, which isn't so bad. It's not a huge discrepancy, but of course, it all depends on what you're trying to do. But we were able to do that. We were able to do this test back then, and we're looking at basically what results we were seeing on the PPB data set. And then after updating with the latest data set, the PPB2 data set, again, we reproduced the experiment to make sure that across the board we were seeing similar results. And that's pretty much true here. And then we did something, we looked at our data and we said, okay, let's see what's going on. Let's dig into this. Let's add some additional training data to make our data sets more diverse and make them more balanced. And once we did that, we were seeing less of a disparity in the error rate for this particular darker skinned female group. And also just overall, majority of the groups were less in error. However, notice that sometimes if you improve error rates in one group, it doesn't always improve in another group. And so these are things to keep in mind because you have to make trade-offs sometimes in your application. That's why it's really most important that you know your use case and what you're developing for and the environment that you're going to deploy in. And then lastly, in this particular study, we wanted to test out where should we place our confidence score threshold in order to see that particular comparison between darker skinned female and lighter skinned female in terms of error rates. And so this plot just basically plots the confidence score thresholds with the error rates for these two groups. And as you can see, if you set your confidence score to something pretty high, like 99%, then both of your groups approach zero error. However, if you were to lower it to something like 50%, then yeah, you will see a disparity between the two. But also keep in mind that the more you increase your confidence threshold, the less results or responses you're going to get from the model. That can be good and bad as well. So keep those things in mind. So lastly, in this particular case study, we wanted to just visually inspect what was going on. So what is the root cause of seeing some of the disparities? So let's first off, now that we have our confidence score, we have confidence that the data set is what we think it is because we've done our data analytics on it. We've also done some testing on it, and it is reproducible from the experiment in the paper. And so now let's take some and just visually inspect what are we seeing as correct results when we put our confidence score up to 99%. So these are ones that we're pretty sure, hey, these are correct. And so we looked at them and said, okay, there aren't anything that really throws me off here. There aren't any errors that I'm seeing. And so this seems to be going well. So let's continue to look. What if we drop that confidence score even more? So let's say we drop it below 99%, and let's look at some that are more like in the 70 percentile confidence score or 80%. And we're still seeing, pretty accurate results when we're looking at darker skinned female, at least according to how they're labeled in the data set. And so seems to be true. So we also did the same for the other groups as well. And here's just an example of when we were looking at lighter skinned female, we were trying to see, again, this is according to how they're labeled in the data set, darker and lighter. We were trying to see, okay, is there anything that sticks out with the correct samples? And all these seem to be, at least visually, lighter skinned females, which are accurately classified as in this term female. Again, we're looking at binary gender with a confidence score of 99% or higher. We did the same for the errors. And so these were for a confidence score of less than 99%. And we noticed that, wow, these confidence scores are kind of pretty high. So there's some like 96%, 90, 95 almost here. So why were these people, at least these are labeled as women, misclassified as men? And we noticed that they all have shorter hair, or they appear to have their hair pulled back, or for whatever reason, it looks like, they have similar hairstyles. And so we took that, and this is what we call a confound variable. And so when we take that and we want to see, okay, if we take a data set, let's go on this theory that shorter skinned women are misclassified often as men. And maybe the same is true in reverse. Maybe longer haired men, which we actually looked at our data set and found that to be true as well. And so now we're on to something. And this is how you get to the bottom of what's going on with your model outside of just adding more data. And so we did that. We also retrained everything. I mean, um, we basically added more differing hairstyles of people to our data set for our trained model. And we're able to test this theory out on many other types of data sets that were not in the PPB data set. And we found that, again, our hypothesis was actually true. And so the more that we did that, we were able to do the same test where we look at our confidence score threshold as it is compared to error rate over many different groups of the females. So we were able to, in this new data set that we created, we were able to look at it and also compare it back to some of those that we pulled from PPB2 and looked at shorter hair versus longer hair. And we were able to see, the discrepancies, where we were possibly going wrong or in the wrong direction, and how to improve for those particular groups. And so this is just an example of what you can do with many different areas of attributes. Now let's apply this one more time to the Fairface data set, which these are similar experiments that we went through this same methodology to test our system. And so we did the same thing. We looked at the breakdown of the data set. We visually inspected it to make sure it was okay. We found that this also offers us the ages of the group of people. I think this data set has had both male and female, at least labeled as male and female in terms of binary gender, and also the age groups all the way up to more than 70, which you can see there's a disparity from the beginning in that group. So I would not necessarily use this data set to test on something that may be used in populations with higher, number of senior citizens. And so we also see that they have a diverse group of ethnicities here. And so we were able to use this and get a similar plot of error rates across the different groups. Two things I want to point out in this plot in this process of doing this. One, we see that if you are looking at the error rate overall, it looks like the error rate is a little bit over 4, between maybe 4 and 5%, which you would think, oh, that's not bad. But if the more you break this down into the subgroups or subpopulations or the intersections of those attributes that we saw labeled on the previous page, you can see more and more disparities in the particular error rates. For example, if you look at female versus male, it seems to be that male error rate is slightly lower than female. Also, if you were to look at across all the groups that they pull out, along with the classifications of the labels of female and male in those groups, the intersections, you'll see different other disparities and ranges of error rates as well. So what does this mean? Of course, this depends on, how what we call mission critical, or how critical is this application of AI? Is this a situation where, someone may be wrongfully implicated of a crime? Is this a situation where someone may cause harm to someone? Or is this more like, okay, this is like recommendations of my music and my songs, which isn't as critical. But either way, know your use case and know what these numbers mean. The second thing I want to point out about this is that these error bars are basically the way you determine how much variance or how statistically, I can barely talk, statistically significant your results are. And so remember, the more reliable your data is, and so the larger the error bars, the less reliable you could think about that these results are. And so some of these have very large error bars, which usually boils down to you probably need to get more data in those particular categories. And so if I were to, and this is a confidence threshold of 50%, by the way. So if I were to raise that confidence threshold to something really high, like 99%, remember when I was telling you earlier, if you set that confidence threshold really high, you're going to get less responses. So you'll see much less data listed here. And you also see these error bars are like huge. And so again, it reduces the reliability of your system. So one, you're going to need to get more data across the board if you're going to have a high confidence threshold of like 99%. And then two, you're going to want to investigate after that, if there are still any disparities amongst certain groups. So again, it's just an example to show you how we think about these things and what the methodology is, and just ways that you can, you know, figure that out. Okay, so in conclusion, lessons learned that I personally have learned throughout the years of doing this and looking into these types of issues is that testing for unseen areas amongst intersectionality is key. Key word there, the intersections of different types of groups. That's where you find the real information. Taking into account confidence scores, thresholds, and error bars when measuring for biases is very much so necessary. There are several papers that don't even show error bars on their results, which is something that should be the norm. Also, representation matters. Representation in your data, representation in those who label the data, representation on those developing the technology, and even in terms of the stakeholders. So think about the customers, think about your end users, think about the people that are, making policies, and the legislator that are getting involved with these technologies, and making sure that you have a lot of people at the table, giving that buy-in, that feedback, and understanding how this affects each and every person. Transparency, reproducibility, and education, it can promote change. That's exactly what we do, exactly what I do as a tech evangelist on our responsible AI team. And so that's something that we really want to drive home. And lastly, confidence in your product's fairness requires fairness testing throughout the iteration of the life cycle. So we cannot assume unless we test. And remember, this is not a one and done, it's a continuous thing. All right. So again, this is paramount that we continue to do this. And we're dedicated at AWS and Amazon. We have several initiatives, Amazon Machine Learning University. You'll be seeing more initiatives coming from them, things posted on YouTube, etc. Also, we have a responsible use of machine learning guide that we'll provide the link for at the end of the talk. There's also AWS AI ML scholarship program. I want to make sure that you all take a look at that to help promote diversity in tech. And then the training and certifications, always something that we try to encourage people to do. And we'll be loading more and more of that as we go. Advancing the science behind responsible AI, making sure we work alongside others to share best practices, to accelerate research and to responsibly develop AI and ML technology, uh, making sure that we're forming partnerships, because it's not just about the industry, it's a whole ecosystem. So you have the K through 12, you have the college and university systems, you have the startup companies, you have the large corporations. Everyone has to be on board and working together. Um, Also, there's many research grants. We offer 20 million. We did an investment in the NSL Fairness and AI Grants Program, and we have over 400 articles. Definitely check out the Amazon .science blog to find out more about that and the conferences that we're presenting in. And I'll just mention really quickly that participating in regulatory efforts is important. We've seen this happen in the EU, and them, jump ahead and taking initiatives towards policy around creating policy around responsible AI, and we're wanting to see the same thing happen here in the U.S. And public policy and regulations at all levels will define the future of AI, and we're actively working to help shape them as a thought leader, myself even as an advocate or an evangelist, and also helping to chart the future of AI and responsible AI. So lastly, the call to action. What can you do now? Continue to explore responsible AI and learn more about it. There are so many areas that are emerging in all those components that I mentioned earlier. So get on board. Uh, Make sure you educate your organizations. Everyone has to be having some knowledge of this as they move forward, because everyone's contribution is important. Make sure you identify your needs. Carefully think about your organization's needs and where AI fits, and make sure you consider risk. There can be many. One thing we like to think about is, what is the worst possible thing that can happen, and how do we work backwards to make sure that doesn't happen. And then lastly, choose diverse talent. I guarantee you it will help you in many, many ways. So thank you so much. This is the link to the responsible use for AI ML that you can find on our blog. And please feel free to reach out to me. I'm available on LinkedIn and other social platforms. Thank you.